Welcome! In this video, you'll learn how to import 3D projects into Fusion, shading, making a 3D dome background, UV mapping, ambient settings, and much more. Let's get started. Download links for the 3D car models zip file, and the sound effects in the introduction are in the description. To rotate the 3D view, hold down the middle mouse button and move the mouse. Select the arrow. To fix the problem with the car's wheels, and reset the values to their default values. Hide the objects you won't export by pressing the H key. Make sure there are no objects left other than the car. Select Layout to continue in the default interface. An overflow appears. Click once to select the overflow object, then click again to make sure you've selected the correct object. Press Tab to enter edit mode. Select the vertex and press G to move it, then Y to move it only along the Y-axis. Press Tab again to return to object mode. There's another problem here. Press / to display only the selected object. The merge value in the mirror modifier is 0. In Merge, click the arrow on the right to enter a value. It's now fixed. There's another issue here. The back face in the middle is flipped with the front face. It becomes visible when shading in Fusion. This part won't be visible in this video, but I'll fix it so you know how to fix it if you encounter a similar issue in your future projects. Press Tab to go to Edit Mode. Select the selection mode as Face. Select the center object. Press Ctrl and plus to expand the selection. If you overselect, press Ctrl and minus to shrink the selection. To include the unselected part in the selection, hold down Shift and click on the unselected part. In the Mesh menu, click Flip under Normals. It's now fixed. Press / again to view the entire car. Press A to select all. Export as FBX. Select the visible objects. Reduce the size so it doesn't take up too much space in the DaVinci Resolve 3D screen. The other options can remain as is. Export. Press Alt and H to bring back all hidden objects. Download images attached to objects. Add a fusion composition to the timeline. Go to the Fusion page. Add a background and connect it to Media Out. Add Renderer 3D. Set the render type to Hardware Renderer and enable lighting and shadows. Import the FBX file you made. Materials are on the left, and objects are on the right. Because interior's material and object names are the same, restarting DaVinci Resolve usually deletes the object. Therefore, change the material name. Add ambient light. And add a dome light. You can download the image I use for the dome light and background for free from the Polyhaven website. You can use any image in the HDR category. This is what I'll be using. Download it as an EXR and JPG. Because the image's resolution is 8K, it causes performance loss. You can reduce the resolution by adding the resize node. Enable the keyframe aspect to preserve the image's aspect. Don't forget to disable the resize node before rendering. I use a transform node to fill the transparent edges. However, if you set the input scaling option under image scaling to center crop with no resizing in the settings, you won't need it. If you see a transform node below the image later in the video after making this setting, just ignore it and know you're not missing anything. Add camera 3D. To keep the pivot constant as the distance changes along the z-axis, connect the pivot z-axis to the translation z-axis, and then multiply it by -1. This way, you can make an animation where the camera rotates around the car by adding keyframe to only rotations Y. To see the reflection of the image in the dome light on objects with full clarity, set the exponent value to 100. The roughness will increase as the value goes below 100. To make the reflection appear slightly lighter on the color, set the intensity value to 0.1. When you click on the object, a line will appear colored to the material it's attached to. You can easily identify the material it's attached to by following the colored line. Temporarily disable the window's visibility to select the objects inside. The platform and interior objects are connected to the same material. You can change their colors by separating them. Connect the image you downloaded to Taillight. If you set the material color to white, you can see the image's true colors. Two materials appear in the plate. Connect the downloaded image to the material name plate. You can change the text by adding a merge, background, and text to the image. Then, connect the image named Break to the material named Break. To darken the image slightly, darken the white color and lower the intensity. For a mirror image, set the diffuse color to black and the exponent to 100. To make a similar look to the Blender image for the headlights, connect the taillight image to the material named Headlight Glass. We'll adjust this later with the Transform node. Add a color corrector. Set the saturation value to 0 to make the color to black and white. Set the opacity to 0.5 to make a glassy appearance. Temporarily disable the lights glass object so you can select the objects inside. Add Shape 3D. Select Sphere. Link the image you added for the dome light to Shape 3D. Disable lighting to display the image in its original color and lighting. For better performance, disable high-quality rendering and motion blur. Enable the front of the cull faces in the object's visibility settings to see the objects inside. Set the base and height subdivisions to 50. To make a hemisphere, start latitude from 0. Make an instance of Shape 3D and add Merge 3D below the main Shape 3D, and link the instance to this merge. To make both objects display the same image, add Replace Material 3D and link the image to it. To change the latitude end and start values in the instance to different from the original, right-click and de-instance them. Drag the line to bring them back to the beginning. Set the scale settings to D-instance, unlock, and drag the Y value back to the beginning. Add UV Map 3D and stretch the image over the objects. Set the map mode to spherical and click Fit. Set the object's radius to 15. Increase the center Y value of UV Map 3D to correct the distortion on the background. The edge is too sharp. To make an oval edge, add Shape 3D and select the torus. Set the torus's radius to 15. Also set the base subdivisions to 50. Make the section value a little thicker by setting the section value to 1. Set the starting latitude to 270. The total value of radius plus section is now 16. For a total of 15, set the radius value to 14. Use D-instance to set the Y value of the instance to a different value than the original. Select the original Shape 3D and set the Y value to 1. Similarly, set the Y value of the torus to 1. Because the torus shrinks towards the ground as an oval with a value of 1, set the instance radius to 14 to compensate. Disable the torus's lighting and enable the front of the call faces. It looks good. There's a problem at the image's joint. We can fix this by slightly adjusting the rotation Y value of UV Map 3D. We've set Camera 3D's pivot. Simply add a keyframe to the rotation Y value to rotate the camera around the car. To smooth the animation, open the spline editor, select the start and end, and press the S key to smooth. Add the Ambient Occlusion node, connect Camera 3D to Ambient Occlusion. To enable Ambient Occlusion, click Renderer 3D and enable Z and Normal in the output channels. Also, for operations limited to specific objects and materials, enable the Object ID and Material ID. To apply it to only the desired portions of the screen instead of the entire screen, add the Override 3D node after the car shell object. This node allows you to assign the same object ID to all objects before it. Limit Ambient Occlusion to Object ID1. First, de-instance the object ID of the instance ground to separate it from the original, then set the object ID to 1. Because the visible ground is the backside of the sphere, it doesn't apply properly. To fix this, add the Replace Normals 3D node after the instance object and enable Flip Normals. It's now fixed. Add another Ambient Occlusion node. Bind Camera 3D. Limit the object ID to 1. And change its values to make the image more realistic. Enabling options like ambient occlusion, object ID, and material ID will slow down performance. Add a switch node. Then add a new renderer 3D. And leave the output channel settings at their default settings. You can use this renderer 3D for better performance when needed. Add a ray effect. Set the threshold to 1. To apply the ray effect only to the materials and objects you want, add brightness and contrast. Then enable Clip White to remove the effect from the entire image. Add another brightness and contrast. Click the object you want to apply it to in the 3D view. Find the material it's attached to. See its material number. Return to brightness and contrast. Enable Use Material and enter the material number. This method allows you to apply the effect to only the materials you want. That's all for now. I'll try to explain how to make the animation in the second video, inshallah. Thanks for watching. See you in the next videos.